Good afternoon to everybody. This is the 25th edition of Tiny Lab Talks, and today we will discuss additive manufacturing as a disruptive processing technology and somehow how additive manufacturing, called by some 3D printing, is going to change the future. Tiny Lab Talks are brief informal talks between two specialists, one invited by the University of Aveiro and another one from the University of Aveiro itself, through the American Corner program on topics such as technologies, innovation, research, and culture. These conversations usually take place at the University of Aveiro American Corner MediaLab with the support of the US Embassy in Portugal. To start, I will present myself. I'm Paula Vilarinho. I'm a professor at the University of Aveiro in the Department of Materials and Ceramics. I'm Vice Director of the Associated Laboratory CISECO, Aveiro Institute of Materials, and I'm a researcher in the field of materials, and particularly electroceramics for microelectronics. With me, to be part of this Tiny Lab talk, I have Lalita Udpa. It's a professor at Michigan State University, United States of America, and Vitor Neto, a professor at the Department of Mechanical Engineering of the University of Aveiro. And you both are related and interested as professors and researchers in additive manufacturing in very complementing ways. So, very quickly, Professor Lalita Udpa research interests include various aspects of development of computational models for the forward problem of non-destructive evaluation, signals, images, processing, something that really are very important in terms of characterization of materials. And I guess that characterizing additive manufacturing parts is still a challenge. We will discuss this. And so it's a pleasure to have you here. Welcome to the university.
Thank you.
Vitor Neto is a researcher and a professor developing work on product development and manufacturing technologies, and especially involving thermoplastics, processing, eco-design, and nanoengineering. Besides being a researcher and a professor, he's also interested in matching scientific research, engineering, and society, and challenging industrial problems, I would say. Welcome, Vitor.
Thank you.
I will be here exactly moderating, so my job here, the way I understood it, it's to ask a few questions and let you talk. So, Vitor, if you allow me, I will start with Professor Lalita. So, from your point of view, how disruptive is this additive manufacturing technology? What is really going to be changed from your point of view?
Well, I don't think I would characterize additive manufacturing as disruptive. I think it's an advanced manufacturing technology, and it offers a lot of advantages. It reduces waste, and also there are many parts where the tools that are needed for manufacturing those can be eliminated by using additive manufacturing. So I think it's a very advanced manufacturing technology, and I wouldn't call it disruptive.
Very good. Vitor,
share
with us your thinking.
Yeah, it's quite dangerous to say it's a disruptive thing, because people might think that conventional ways of producing things will be eliminated. That's not true. We're going to still continue to use the conventional ways of injection molding, welding, metal machining, etc. But additive manufacturing, for sure, it's coming to give us more freedom of design, the possibility of building geometries that were impossible in other technologies, besides, of course, adding new possibilities of sustainability, of local manufacturing that can gain a lot on terms of eco-design and sustainability.
I think, Vitor, that you mentioned something quite interesting as the comparison with the conventional technologies. One of the things I face currently is that the industry tends to compare additive manufacturing with the current technologies. Is this really comparable?
No, it's not.
No, these are, I think, two, it's like subtractive versus additive. So there is a world of difference between the two. And additive manufacturing, one other thing I would add, I have seen in my lab that very often when we are doing having an experimental setup, it needs a single part, a fixture that needs to be manufactured. Students can now go, there's an 3D printing machine, they just, whether they fabricate in the matter of a couple of hours, and we carry on the experiment. So there's a lot of advantage, that it offers here.
Absolutely. And research like Professor Lalita is doing, it's crucial for what we conversated a while ago, and for what I researched a little bit on your research. It's fundamental even for this kind of applications of additive manufacturing, replacing some parts where we need to understand very well what's going on inside of the parts. And it's true for conventional, if we are doing bulk metal parts, foundry, etc. It's important to know the bulk properties of it, how it's inside. Well, it's even more important when we do it in additive manufacturing, where sometimes we even want to have bulk parts inside, so we can have lighter parts and all. And research like the one that you do is crucial for that.
That's right. Design optimization.
Design optimization. Absolutely.
This is quite interesting, I think I see myself in all of your words, so whenever I teach, I always say this is an amazing technology and this will facilitate everything, we will change the world with this, etc. I'm so enthusiastic. But then, when I really look at the reality, I still think there are struggles. So my next question was, in all of these processes, as you were mentioning, you are developing techniques to help to improve. So what are the main challenges that this technology is currently facing?
Okay, I think there was some of the challenges that Satish pointed out in the talk. When you have a different physical process, there are other things that that play a role, and sometimes it leads to defects in the manufactured part. So one of the challenges is that as you are manufacturing a part, you need to have a method in place that will do the quality control, will detect if there is any problem. Can I in real time control maybe the feed rate or the laser heating to optimize the design and to eliminate any defects that can form during the manufacturing
like
process.
an in situ control.
Yes, in situ control. So those are some of the challenges that I can think of right now. I don't know if you want to add some more.
Even if you want to control, to keep that quality control that you were saying through its lifespan.
Yes,
it's very interesting.
So not only manufacturing defect, but in-use defect too. My area of research is really detecting defects. Detecting defects
So
in things that are as large as a bridge to something as small as an additively manufactured part.
Yes.
So we both work on developing sensors that will detect these kind of defects, and that's what we were trying to talk to.
And I think this is very important because one of the things that we know from the literature and from the science is there's still a lot of defects that are created during the process and needs to be eliminated. Especially if we want to go to this defect-free industry in which we have no defects, no wastes, etc. Almost perfect.
That's right. Yeah,
Let's see.
really.
Vitor, any comments on this?
This will not change the world, but we hope it changes a little bit. It adds a little bit to the world. Because it's in fact a technology or a group of technologies. When we're speaking about additive manufacturing, in fact we are speaking about a very big branch of different technologies in itself. And I never stress that this is adding new possibilities to things that we are doing, and people need to understand each one of this single technology. My favorite, of course, is FDM, fused deposition modeling, but selective laser melting. All of them have particularities that will allow us to produce products with better sustainability, for sure.
Right, and I think the proof of the viability of this technology is if you look at the number of companies that have started following this. It has increased
Increased
exponentially.
tremendously.
And clearly people see the value of that.
So when I do my readings, and because as I said, there's a topic that interests me, and we have projects with companies I'm teaching. We have a master on additive manufacturing in this university, so the topic is really important for me. One of the things that I've noticed is that people say, even some reports coming from Europe, that we have shortage of well-trained and skilled technicians familiar with the technology and capable of applying 3D printing. So my question to you, and then also to you after Vitor, is how to attract people to get a degree of this topic, and on the top of that, females as well.
Okay, that's a common question, how to get more females into manufacturing, engineering, and so on. I think, like any new technology, it's going to take some time to have a trained personnel for doing this. But I think the amount of training that you need for 3D printing, for doing 3D printing, is much less than conventional manufacturing. So I don't think that's a great challenge. That's going to be a problem in future. I think even now, I know there are high school students who all have a 3D printing machine at home, and they they know how to program it. It's happening even as we speak.
Okay.
Yeah, it's true.
Yeah, agree.
Especially use the position modeling. It's a very cheap technology that kids can have access to it in schools, in places like here, the American Corner, where they can try it. My kids at home, they start trying it at a young age. Unfortunately, maybe for that, my daughter went to engineering. I'm not sure if it's only for that, but probably that also contributed.
Yes.
So giving them the possibility, hands-on, the technology, additive manufacturing puts it as probably no technology did it so far.
Following this discussion of, because indeed this is a technology, and we expect it to be able to produce parts, and some big parts, etc. So, but as new as it is, and also because it combines different areas and it's very interdisciplinary, my next question is, and as we were talking minutes before we started, I've read that the National Science Foundation invested considerably in research and development in additive manufacturing. So this is just to ask you if this is correct, and if you are aware of the impact of that. And in your opinion, how these science foundations can really help to push this technology to be more implemented and more well regarded.
Yeah, the National Science Foundation basically funds fundamental research, and as Satish pointed out in the talk, in this technology there are a lot of things that can be done to improve, and in order to do that we have to get back into the fundamentals, do the simulation, and see the feasibility of how we can improve. All this optimization can be done much more effectively using simulation models. And so National Science Foundation has a specific initiative on advanced manufacturing, and they've been increasing the funding in this kind of area. And again, that goes to show that a lot of people are seeing the value of this research and this technology.
How do now? Just a thought that crossed my mind. How do you relate this with this artificial intelligence that everybody speaks now?
Well,
is there any relation from your point of view?
I don't directly see. Maybe in the optimization of the design, we could have simulation models with AI to do some kind of a digital twinning, and use artificial. Again, AI is also a tool.
Yes.
And so is
that's why I was asking.
Yes. Yeah. So it can be integrated with the manufacturing process.
Well, we are using a lot of, we are trying to use a lot of generative design to optimize, to open new possibilities of design, and when I say design, shapes of objects, structures that we need to produce in somehow that need to support some strengths, and we might use artificial intelligence to optimize all of that, taking advantage not only on the materials, on the technology, but the creativity that it will assist us to have. Okay.
Right. And I think one more way is, when we talked about in situ monitoring, that means you're getting data on the quality of the part. This data has to be interpreted in real time and used for controlling the manufacturing process. So AI does that very effectively. And there are quantum AI systems that can even do it even faster than regular AI.
So this takes me to our previous question. When, maybe to operate a machine, we don't need, it's not going to be so difficult to train people. But to use these sophisticated tools to improve, maybe we really need to have people that is skilled on combining the two things, right?
Right, and I think in the case of, I'm not an expert on AM systems themselves, but it's basically driven by software, by CAD design, model design. So it's driven by that. And so I think more of the engineers will be doing the designing the model on using this software. And once that is done, everything is automatic.
I can share with you the challenge of one of my PhD students is to recycle plastics, namely PLA from former additive manufacturing parts. And when you're recycling, what you're getting is parts of plastics with different characteristics that you probably need to tune to get the proper characteristics of that part that you will then produce. Well, one of our focus is to use artificial intelligence to understand the characteristics of that plastic in its flow, so in time we can do mixing of some additives that will compensate the loss of properties. So this is a thing where I believe that artificial intelligence will also assist us.
When we were listening to the talk this beginning of this afternoon, we were talking about metals. One of the things that is commonly said is that there's a lack of materials for additive manufacturing. A lack. Because additive manufacturing will transform the metallurgical industry or metal-based industry, but it's also supposed to be used, for example, in composite structures or ceramics or even plastics is being used on a regular way. So what should we really do in order to develop more feedstock, a wider feedstock range for additive manufacturing?
Well, right. The powder and wire feedstocks are one that we've been basically familiar with. I don't know what are the other types of feedstock, but in general, I don't see that as a problem because many material are available in wire form. And in fact, one of the things we were discussing before this was using multiple materials. I think he touched on that during the talk too. You can have, if you want to make an alloy, then you have to manufacture the metal alloy and then use that for manufacturing a material, a part. In additive manufacturing, you can do it in situ too. You can have multiple wire feed of multiple material melted, and by controlling, you can control the alloy composition and the properties of that alloy. There's a lot of things that you can do.
I fully agree with you. As I said, I'm an early adopter, and I do believe on this, and I also believe in the potential of sooner or later making structures additive manufacturally atom by atom. That's what we really want. Eventually in the future. So I believe that. But when we really talk with the companies and try to develop projects with companies, and we have several students that were trying to do that, there's always some struggles, either because the feedstock is not the appropriate one, either because it's very expensive, or the number of defects and how to standardize standardize the qualification of these parts. So I still this.
Well,
Problem. Okay.
for sure, there's room for a lot of research and fundamental research, because a while ago we were speaking about different technologies in additive manufacturing. Well, different technologies are needed because materials are processed in different temperatures, forms. All the even SLM, selective laser melting of metals. Most of the times you buy equipment and you buy a certain laser that's only capable of melting a certain type of metal. If you want to change your feedstock for another one, probably you need to invest in another laser. Well, the future, I believe that we will have hybrid equipment
Systems,
to do composites really in an additive manufacturing manner, but we are not there yet. And for that level, we need to do a lot of research on it still.
I think the basic algorithm or the procedure is there, but there are so many parameters that needs to be optimized depending on the application or whatever.
But I think I would like to get back to the topic of the females. How do we attract, Vitor, I'm very sorry, but I think this is also relevant. We have a couple of females engineers here. I'm a female engineer, although I've never did properly engineer, I'm a professor, but I think this is also relevant. So I would like to listen to your experience, how we do this.
This is a problem that I've been struggling with. I've been in academia for 30 plus years. And the first thing I do when I go into an undergraduate class is count the number of students, count the number of females. And unfortunately, I've seen that number is creeping up, but very, very slowly. So we do have, in Michigan State University, we try to do a lot of things to promote more women to come into engineering. We go down to the sixth graders. There is one symposium for sixth grade girls where we go and, we have a lot of female faculty go and give talks and try to motivate them. There's also the College of Engineering, the Society of Women Engineers. They go to the middle school. So we do a lot of talking to the girls in school level. I mean, we have to do it at that stage in order for them to, study engineering and after they finish school. So it is a problem, and I'm still struggling with the magic bullet, that will solve this problem. And anybody has any suggestions? It is a problem that has not. I haven't been able to fix it very effectively. But for my daughter, I have a daughter who, when she was in the 10th grade, I coupled her with one of my chemical engineering professor, it's another woman, and she worked for 3 months over there, and that is what motivated her. So right from school, so every summer she spent time in chemical engineering lab. So she, and this person works in tissue engineering, so it's more biomedical, and biomedical engineering has been attracting a lot of women. So maybe we have to give engineering a bio slant to get women into engineering.
Yeah, we have exactly the same problem. Maybe Vitor, coming from a materials department, a mechanical department, sorry. Any comments?
Well, mechanical engineering attracts about 10% of girls each year, more or less. Some years more, a little bit less, depends. My point is, we need more role models, and fortunately or unfortunately, a lot of women engineers, a lot of engineers in general, with their professional development, they go for management activities, and then you are not anymore a role model for engineering. But we need those, because probably my daughter came to engineering because I was an engineer. Most of the girls and the kids, they always follow some kind of role model. Then we have to highlight, and it's great that I am here seated with two engineers to be role models for
Yes,
girls.
Not exactly sure if I will be a great role model in the sense that I never practiced in the industry, you know.
Me too.
Okay, so you see, so I've been reading. This is something that really makes me think. What is the reason of this? And I guess there are really biological reasons.
I think I understand the reasons. So if you watch television and you look at that commercials, when it's a little girl, the toys are always Barbie dolls and things like that. Whereas the toys for boys are always trucks and building things. So I think we need to change society at that level to because television is a very powerful media, and every kid watches that. And I think if we can change society at that point and we can get girls into engineering.
Okay.
If we can do that.
Maybe the next American Corner should address the topic of using these TV commercials to help us to change the society. Because I was thinking that additive manufacturing as a kind of a more, I'm going to use a word, cleaner technology would somehow be more attractive too, because some of these heavy metal industries are really and we have some companies here in which we see the old parts of manufacturing and then we go into the new parts of manufacturing. It's so clean, so tidy that maybe women feel. That's why I was asking, maybe additive manufacturing could be also a way of doing that.
Yeah, that's true.
I think we are reaching
Men are also like clean stuff, okay?
No, I'm not saying this is a topic that is very delicate and that some can be misinterpreted, and I don't want to go in that direction at all, Vitor. But indeed, there are situations in which we feel eventually better than others, and I really, But I think diversity is very important. Yes. At least in my classes, this is being very powerful, and I think the industry the same, because we see things in a different way. It was a pleasure I think we are reaching the end, right? So it was a pleasure to talk with you both. The thematic is very relevant. We are not going to solve all the problems of the world, but I think we have contributed to push additive manufacturing technology. So it was a pleasure to have you here, Vitor. Thank you very much for your time.
Thank you. It was a privilege to be here.
Thank you very much. It was a pleasure.